This is the intro video for section 9.1 in Algebra 1. We're going to be looking at how to solve quadratics using the square root property. So let's review what the standard form of a quadratic equation is. It is ax squared plus bx plus c is equal to 0. In this case, the a and the b and the c all stand for constants. In other words, they're numbers, like 7, 5, -3, 12, whatever. It is of degree 2, right, x squared. And then one of the more important things we've looked at in recent days is that for a quadratic to be in standard form, it needs to be everything on one side equals 0. Okay, so in a very specific case, which we're going to talk about today, when b is equal to 0, or perhaps the quadratic has been carefully kind of rearranged, then you could use the square root property to solve in a very efficient way. So the square root property is very simple. You can square root both sides of an equation, and that is permissible. So the square root of x squared would give you x, and the square root of c would give you root c. We're going to find out that when we do this, when we square root both sides as a means to try to solve an equation, we need to put plus or minus in front of the square root of c, simply because the square root of c squared gives you c, but then also the negative square root of c also gives you a positive c, because a negative times a negative is a positive. So we're going to try to use this property in a couple of examples here in this video, and then we'll do some more when you come to class. Okay, so we're going to do examples 1 and 2 here. So here's how we would do example number 1. The first thing I would do is I would notice that as this is currently written, the b is 0, right? A is 1, c is -15. There is no middle term, so b is 0. So to use square roots, the first thing I'm going to do is I'm going to add 15 to both sides. Remember, this works well in certain arrangements and when b is 0. So then 0 plus 15, of course, is 15. And now that this x squared is by itself, the quantity being squared is by itself, I can square root both sides. So when I do that, I end up with x equals plus or minus the square root of 15. If I wanted to, I could approximate the square root of 15, but I'm just going to leave it as is, keeping the plus or minus. Both the positive and the negative versions of root 15 will work just fine. And then example number 2. Example number 2 has been carefully rearranged, and we're going to actually work on doing this rearrangement later on. But it's been rearranged to where the left side is simply a quantity being squared, and then, of course, equals 25. So in a case like this, what we can do is we can square root both sides right away to get rid of the squared. When I square root the left side, the square root and the squared cancel out. This gives me x minus 4 equals plus or minus the square root of 25. We know that the square root of 25 is 5. So x minus 4 equals plus or minus 5. To finish this out, I'm going to add 4 to both sides. We want to be super careful here. I'm going to add 4 and add 4. Remember that the right side is two different numbers. It's plus or minus 5. So this would give us x equals positive 4 plus or minus 5. To finish this out and find my final answers, I'm going to split this up. So x equals 4 plus or minus 5 is really x equals 4 plus 5, or x equals 4 minus 5. I'm going to split up the plus minus. So then 4 plus 5 is 9. 4 minus 5 is -1. And those would be my two answers. If you plug both of those in, they should check out fine. Okay, so that's our intro video. When you get to class, we'll do some more of these examples. I'll see you then.